So I got some questions about how to figure out the equations of rational functions from graphs. So I have just a couple examples here to walk you through this. So if you've been graphing rational functions, some of this should make sense, and then maybe there's just a few other points of this that you didn't fully connect. So I've got this graph here, and the easiest place to start to help you start figuring out the equation of this graph, or this function, would be to look at the vertical asymptote. So here's my vertical asymptote. So I notice this is the asymptote. So it's 1, -1, -2. So this is x equals -2. So the interpretation then is that if this is the asymptote x equals -2, it's always those opposite signs then that go in the equation, right? So hopefully you've made that connection at this point. So x plus 2, the vertical asymptote, that's always something that ends up from the denominator, right? The work you do in the denominator. So x plus 2 is definitely going to go in the denominator. So we're on our way to starting this. Now, the weird thing about this graph is that it has this hole. And so interpreting the hole actually is pretty simple. So notice the hole happens at, let's see, 1, 2, 3, x equals 3. So the interpretation here is that holes indicate, just in general, if you knew this or not knew, no, now you know, holes indicate there's a repeat factor on top and on bottom. So if I have x equals 3 here, so it's always opposites, right? The opposite factor. So x minus 3 is going to be the factor. And when we see a hole, we just know it's going to be on top and on bottom, like you see here. Okay. And then the last big thing that we need to see with the graph is the x-intercept. So I have the x-intercept. This is the x-intercept, x equals -1. Once again, the factors always work in opposites. So x plus 1 is a factor. And your factors for the x-intercepts, those go in the numerator. And so now, check it out, I've got an equation. So now that just the question is, am I done? So there's one big hint to help you figure out if you are done, namely this asymptote here. This is the asymptote y equals 1. You can only get the asymptote y equals 1 if the degree of the top and the bottom here are the same. And so yes, these are definitely the same degree. This is degree 2, this is degree 2, so we're good. So I can leave my polynomial like this, or if I want, I can multiply everything together like we see here. Tomato, tomato doesn't really matter, but there is the equation of the rational expression. So I want to just do one more of these. So again, just interpreting information. And you can do this whether you have a graph in front of you or whether you've just been handed the information. It's the same interpretation. So just using this graph. Okay, so I'm told that, or I can see, right, that I have, here's my vertical asymptote, here's my other vertical asymptote. So I've got these two vertical asymptotes. So I have, this would be just x. So when you have the y-axis, you think of this as x minus 0 or x plus 0, which is just x, right? And then this one, since this is x equals 2, that means that x minus 2 will end up in the denominator. So there are your asymptotes for there are your pieces for the denominator. And then, so in this case, I don't have any holes. So really the only other thing I have to really look at is where is my x-intercept, which is right here. So since I have positive 1 here, x minus 1 is going to be in the numerator. And then it's like, okay, am I done? So in this case, this is degree 1 on top, degree 2 in the bottom. So if you look, I have y equals 0 as an asymptote here. So this all makes sense. This all works. So we're all good. So this must be the equation. Okay, and so that brings us to the end of that example video. So hopefully that cleared up some questions for you. I will talk to you next time.